Hello there, my name is Hayal Abdullayev and our team name is CodeWave. Today I'm going to present our project called Vehicle Count Prediction from Sensor Data. The main goal of our project is to predict the number of vehicles for the next hour using historical traffic data and neural networks. So now I will first explain the dataset, then I will explain what we did with the data, and finally I will explain the code and the model in detail. So first of all, I briefly explain the dataset. So we have got our data from Kaggle. The dataset contains traffic sensor data, where each row represents the number of vehicles counted at a specific time. So basically, the dataset has two main parts: the time information and the vehicle count at that time. So the data covers a long time period, so it is suitable for time series prediction. So what we did with the data, before training any model, we first explored and cleaned the data. So we have checked the structure of dataset, converted the time column into data time format, and set it as the index. So this allows us to treat the data as a time series dataset. So we have also analyzed the data using statistics and also visualization to understand traffic behavior. So first of all, I'm going to explain from that analysis file. So in this file, there are lots of information out there, and there are lots of steps and codes. So I will briefly explain, and I will only highlight the important ones. So first of all, in this notebook, so we first inspected the data using functions like head and info. Okay, so before we dive into, so we have successfully loaded the data frame, as you see, and so then we first inspected the data using functions like head and info functions. So this helped us verify that there are no missing values and that the data types are correct. So secondly, we have statistical summary. In here, so we use the descriptive statistic to understand the average, minimum, and maximum vehicle counts. So this gives us an overall idea about traffic intensity. So then we have like visualization. So it's here. So we plotted the distribution of vehicle counts to see how traffic is spread across time, and we also plotted the first 30 days as a time series graph to clearly observe daily traffic patterns. So from these plots, we can clearly see repeating patterns such as rush hours and low traffic hours. So this is our output, as you see. So everything is here, and then we have dataset. It's here. So okay, first of all, what we do, data preparation. So in the data preparation part, we transform the raw data into sequences. For each prediction, the model looks at the previous 24 hours of vehicles, counts, and tries to predict the next hour. For example, if we have traffic data from 1 p.m. to midnight, so the model used these 24 values to predict traffic at 1 a.m. And we also add the time information, such as hour of the day and the day of the week, because the traffic strongly depends on the time. So the important one, I'm going to explain it's here. This one. So in here, first of all, what does that do is, so reads the CSV file, and it converts the data time column into the data time format, and also sorts the data by time. So this code ensures that the data is in the correct chronological order, which is very important for time series models. And we have make features. So as you see, it's in here, and we have the loop here. This one does creates sliding windows for 24 hours. Each window becomes one training example. And we have time. It's called time feeds. So in the time feeds, so it extracts the hour of the day and the day of the week. These are added as extra features, and also the model learns not only from past traffic but also from the time context. So we have a scale, scale train, wall set. It's see here. So first the explanation of this part is like scales values between like 0 and 1 and uses only training data to fit their scalar and also prevents data leakage. So this helps the neural network train faster and also more stable. So then we have model. In model, so what we do, like concept is, our model is based on LSTM or GRU system, which are like neural network designed for time series data. The sequences of vehicle counts is given to LSTM or GRU like layer to learn temporal patterns. Then we combine this like this with time features and predict a single value, which is the vehicle count for the next hour. So for the like code explanation, first sequence input. So first of all, so I'm starting from like sequence input from this part. So the explanation is input shape like 21 and 1, it's equal to 24 hours. LSTM learns patterns across time, and LSTM helps the model remember long-term traffic patterns. So if we have time input, it's adds hour like it adds hour and the day of the week information and combines it with LSTM output. So this helps the model understand when traffic usually increases or decreases. So we have out and dense. So explanation, like in here it's like outputs one value, and this value is the predicted vehicle count, and we have finally the train file. So what we do, the concept is the train file like connects everything together. So it loads the data and prepares features like builds the model, trains it and evaluates it, and also like it saves the result. So code explanation for this is, so first of all, the argument parser in this part. So as I said, I am only going to highlight the important ones because there are actually lots of information out there. There are lots of steps, there are lots of functions. We just need to declare and explain the important ones. That's why I'm just doing like summarization to make it better. So we have here the model parser add argument model choices, as you see here. In here it allows choosing LSTM or GRU and also makes the script like flexible. That's why we use it. So then we have trainer, like train end and value end, this one. So this is 70% training and 15% validation and 15% testing. So it keeps time order, not random, like not random shuffle. And this is important because like future data should not be used to predict the past. And we have model. So we have model fit, like model training. Let me see, yeah. So in here, the model like learns patterns from historical data, and also validation data checks performance during the training. And we have it's here, yeah. Y-pred and model predict X tests. So in here, the explanation of this part is, I think this is evaluation. It converts predictions back to real vehicle counts and makes the result like interpretable. And also saving inputs. So yeah, they have save model. And here, so this in here, that function does saves trained model and also saves like metrics and plots automatically. So this allows us to reuse the model without retraining. Yeah, that's all. In conclusion, our project demonstrates how LSTM and also GRU like models can be used to predict traffic using historical vehicle count data. So by combining past like values and also features, the model learns daily and weekly traffic patterns. So this approach can help in traffic management and future planning. So, so we like if I'm going to explain briefly, so we explore traffic data, prepare time series features, and train it an LSTM and GRU model, and predicted vehicle counts for the next hour. So this is my presentation and also my team's presentation. So thanks for listening. Have a good day.